In this video, I will show you how to configure the pins on your BeagleBone Black for Debian 8.6 as PWM pins. And for this video, I'll be using the buzzer on this board, and I'll leave a link on the description below over where you can buy this board. Right now, I SSH'd into my BeagleBone Black, and here on my right side, I have the figure showing which pins on the BeagleBone Black can be configured as PWM pins. And you can access these figures by opening the browser and typing in the IP address of your BeagleBone Black. In this video, I will actually be showing you two ways to configure the pins as PWM pins. For the first method, you shouldn't have any device tree overlays exported, but for the second method, you should have the universal and device tree overlay exported. And if you're not sure how to export or unexport device tree overlays, go check out my previous video I made on exporting and non-exporting device tree overlays. So let me make sure that I don't have any device tree overlays currently exported. And I do that by printing the contents of the slots file using the cat command. So cat, then type in the path to your slots file. I previously created a variable called slots, which points to my slots file. So for Debian 8.6, this is the path to your slots file. And if you don't have a variable created, you can also do cat and just type in the whole path to the slots file. You should get the same output. So here you see that all of my device tree overlays are unexported. And the reason why you want to unexport your device tree overlays for this first method is because some device tree overlays, like the universal and device tree overlay, might be using some of the pins that we want to configure as PWM pins. And if you try to configure a pin that's currently being used by another device tree overlay, you'll get a message that says something like file already exists. Now, after you unexport all device tree overlays, let's cd into the following directory: cd lib/firmware. Let's clear the screen and let's print out the contents of this folder. So here you can see all of the device tree overlays that you can export and unexport. And if we scroll up, we can see that the PWM device tree overlays that we can export are BB-PWM0, BB-PWM1, and BB-PWM2. Now let's go ahead and open up again the figure showing which pins can be configured as PWM pins. So currently my buzzer is connected to pin 22, which is the pin that I'll be controlling. And here you can see that pin 22 and pin 21 end with 0A and 0B. And there's other pins that end with 1A, 1B, or 2B, 2A. Now the numbers map to these three device tree overlays. So to control the pins that end with a 0 and a letter, I need to export the device tree overlay BB-PWM0. If I want to control the pins that end with 1A, I need to export the device tree overlay BB-PWM1. And for those that end with 2 and a letter, I need to export the device tree overlay BB-PWM2. Now here you can see that there's actually multiple pins that end with 0A, 0B, or 1A and 1B. And just by playing around, I've realized that the pins that can be controlled with these three device tree overlays are actually pin 21, 22, 14, 16, and 13 and 19. Now let me export the PWM0 device tree overlay. And I do that by writing to the slots file using the echo command. So echo, open double quotes, BB-PWM0, close double quotes, the redirect output symbol, followed by the path to your slots file. Now if we print out the contents of the slots file, we can see that the PWM0 device tree overlay is now exported. And by the way, any device tree overlay that has an L means that it's exported. Now that we exported that device tree overlay, let's cd into the following directory: cd/sys/class/pwm, and let's print out the contents of this folder. Here you can see that we have PWM chip 0, and if we export the other device tree overlays, the other PWM device tree overlays, we should have other new folders created with a similar name. So I'm gonna go ahead and export PWM chip 1 and PWM chip 2. And now if I print out the contents of this directory, you should see two new PWM chip folders, PWM chip 2 and PWM chip 4. Now, like I mentioned before, based on the name of the device, the PWM device tree overlay that you exported, you should be able to kind of tell which pins you can control. But now let's say that this is all you have and this is all you know. Now, how do you know which one of these folders controls which pins? And to know that, you need to look at the technical reference manual. Here is the AM335X Sitara technical reference manual, and I'll post a link on the description below. But once you're here, scroll down to this link and go ahead and open it. Now what you want to do is scroll down to the memory map where the PWM pins are mentioned, and that should be around page 182. And here you can see that we have the address of our PWM pins. Now if we go back to our terminal and let's keep this window open, you can see that each one of these folders ends with a number, and that's the address of the pin. So the address that the PWM chip 0 folder maps to is 483.00200. PWM chip 2 maps to 483.02200, and PWM chip 4 maps to 483.04200. And by the way, you might have different PWM chip numbers, but it doesn't matter. What matters is this number right here. Now first let's take this number, the number that's mapped to PWM chip 0. And now let's look for that address in this table. And you can see that that address appears here right next to EPWM 0 and under PWM subsystem 0. Now based on that, you know that in this case the PWM chip 0 folder will be used to control the pins that end with 0A or 0B in this figure. And now if we look at PWM chip 2 and look at the last four numbers, 2200, and look for them here in the table, we can see that they're under PWM subsystem 1. So that means that the files within the folder PWM chip 2 will be used to control the pins that end with 1A or 1B within this figure. And now let's look at PWM chip 4, and the last four numbers are 4200, and we can see that those appear right here as well under PWM subsystem 2. So in this case, PWM chip 0 will be used to control the pins that end with 2A or 2B. And like I mentioned before, my buzzer is connected to pin 22, so it should map to subsystem 0 since it ends with 0. So I should be working with the directory that has the address of 0200. And if we go back to our terminal, we can see that that directory is the PWM chip 0 directory. So let's cd into the directory that ends with the address 0200, and for me that would be PWM chip 0. And now let's print out the contents of this directory. So here you can see that you have several files. The two files that we'll be working with on this directory is the export and unexport files, and those are the files that you write to export or unexport your PWM pins. And let's look at our PWM figures one more time. So here you see that pin 22 ends with 0A and pin 21 ends with 0B. So to export pin 22, I need to write a 0 to the export file, and to export pin 21, I need to write a 1 to the export file. So basically, if your pin maps to an A, you write a 0, and if your pin maps to a B, you write a 1. So back on our terminal window, let's go ahead and write a 0 to our export file using the echo command. And if we print out the contents of this file again, we can see that a new directory was created, PWM 0. And if we were to write a 1 to the export file and print out the contents of this directory, we could see that a new directory was created, PWM1. So let's cd into PWM0 since that's what our buzzer is connected to. Let's clear the screen and let's print out the contents of this directory. And now here you can see that we have several files. The two files that we'll be working with on this video are the duty cycle file and the period file, and these are the files that you write to set the duty cycle and the period. Also, the values that you write to these two files should be in nanoseconds. So let's print out the contents of both of these files just to see what we have. Duty cycle is set to 0 and period is set to 0 as well. Also, I forgot to mention the enable file is the file that you write to turn the pin on or off. So if we see the contents of the enable file, we can see that our pin is currently off. So first, let's go ahead and set our period by writing to the period file, and I'm going to set the period to 100 milliseconds. So I use the echo command and enter 100 milliseconds converted into nanoseconds. And now I'm going to set my duty cycle to 50%. So again, it's just going to be half of that. And now to turn on the buzzer, we write a 1 to the enable file. Now if you hit enter, you should hear the buzzard. So let's clear the screen. Now let's change the duty cycle to 25%, and the sound of the buzzard should change. And now to turn it off, we write a 0 to the enable file. Now let's go back to our previous directory, and to on export we write a 0 or a 1 depending on which PWM we want to unexport. We write it to the unexport file. Now if we print out the contents of this directory, we should see that the PWM 0 directory is now gone. Now an issue that I found with this first method is that you can only control 2 pins at a time. So if we cd back into our main PWM directory, and let's go ahead and print out the contents of this directory, you can see that you have 3 files. So we have 3 files, and like I showed, we wrote into the PWM chip 0 file to control pin 21 and 22. Now you would assume that to control pin 14, 16, or 13 and 19, you could write into the PWM chip 2 or PWM chip 4 directory and follow the same steps that I just showed. However, that's not the case. What I found out is that with this first method, you can only control the PWM pins of the device tree overlay that you exported first. So because we exported PWM 0 first, we were able to control the pins that map to that device tree overlay, which in this case were 21 and 22. But right now, if we wanted to control pins 14, 16, or 13 and 19, it wouldn't work. So if you wanted to control pin 14 and 16, you would have to unexport the device tree overlays, restart the BeagleBone, and then export the PWM1 device tree overlay. And same thing if you wanted to control the pins that map to the PWM2 device tree overlay, in this case 13 and 19. However, with the second method that I'll show next, this is not an issue. You can control several PWM pins at a time. Now for our second method, we're going to be using the config-pin command to configure the pins as PWM pins. And in order to be able to configure them using that command, we need to export the universal and device tree overlay. Now I explained how to do that in my previous video of exporting and unexporting device tree overlays, but I'll cover it here real quick. So you can see that currently I don't have that device tree overlay exported. So to export it, I need to edit the uenv.txt file located under the boot directory. So I'm going to cd into boot, and if I print the contents of this directory, you can see the uenv.txt file. So I'm going to go ahead and edit it using the vim command. Now the reason why my cape universal and device tree overlay is not exported is because I commented out this part of the command that actually exports it. So I'm going to go ahead and uncommented it. So I hit the I key to insert characters, then backspace to delete it. To save the file, hit escape, then shift semicolon, then WQ for right quit, hit enter. And if I print out the contents of the slots file, you can see that it is still not exported. So that these changes can actually be applied, you have to reboot your BeagleBone. So that's what I'm going to do right now. So if you're signed in as root, you can just type in the reboot command, hit enter, and it should reboot. After you reboot your BeagleBone Black, let's print out the contents of the slots file to make sure that that device tree overlay was exported, and you can see that the universal and device tree overlay was successfully exported. So now if we cd back into the previous directory we were in, which is sys class PWM, and let's print out the contents of this directory, we can see that there are already some PWM chips folders in here. And if we cd into one, so let me cd into my first chip, PWM 0, you can see that we have the same files that we had before when we exported the PWM 0, 1, or 2 device tree overlays. And we can actually go ahead and export one of the pins, so 0 or 1. And if we do that, and let's print out the contents again, so you can see that here I have PWM 0. So if I cd into it and print out the contents of this folder again, you can see that the files are still there. Now if we were to write to them the same values that we did previously, we wouldn't get an error, but our buzzer wouldn't buzz. And the reason for that is because your pins are still not configured. So even though you can access all of these files, you still have to configure your pins. And to do that, we use the command config-pin. So let's go back to the main PWM directory. Now again, your folders might not say PWM chip 0, 2, 4, 5, or 7. You might get different numbers, but it doesn't matter. Now the way that you can tell which of these folders you need to write to control the pins, an easy way is by looking at this part right here. You can see that this ends with PWM, but these other two, PWM chip 4 and 7, ends with ECAP. So 0, 2, and 5 should be the directories that you use to configure to control your pins, but you still don't know which folder controls which pins. So remember, we have 6 pins. And again, to see that, we look back at our memory map. Now looking at the contents of our folder, PWM chip 0 maps to the address 48300.200. So if we look at the memory map, we can see that subsystem 0 maps to that address. So for this case, PWM chip 0 will be used to control pins 21 and 22, since both of those are of PWM 0 subsystem. So again, because my buzzer is connected to pin 22, which maps to subsystem 0 or PWM chip 0, that's the pin that I'll be controlling in this example. So now let's look at the config-pin command. So let's go ahead and type in config-pin --help, and here we can see that one of the options is to use the -l command followed by the pin number to see how we can configure our pin. So if I type in config-pin --l followed by P9.22, which is the pin that my buzzer is connected to, so P9.22, hit enter, we can see that we can configure our pin as GPIO pins, SPI, UART, I2C, PWM, and PRU. And PWM is the one we're interested in this example. So now to configure it, we use the same command, config-pin followed by the name of the pin, so P9.22 space, then PWM, hit enter. And I think if we type in config-pin when we use the I option, it should tell us what mode our pin is in, and that actually didn't tell us much. So let's cd into the following directory: sys devices platform OCP, and let's print out the contents of this directory. So here we see our pin that we just configured, pin 922. So we cd into that directory, so OCP, then P9_22, hit enter, let's clear the screen, and let's print out the contents of this directory. We can see that there's a folder called state. So if we print out the contents of that directory, we can see that it says PWM, and that's what our pin is currently configured as. So now let's cd back into our main PWM directory. Let's clear the screen and let's print out the contents of this directory. So now that we configured pin 22, we can cd into pin PWM chip 0, or it might be a different number for you. As long as you're cding into the directory with this address, it's fine. Now let's print out the contents of this again. Now we already exported our pin 22, and remember 0 is A and 1 is B, so we can see that PWM 0 is already exported. So now we cd into that. Let's clear the screen and let's print out the contents of this directory again. And now let's check out the current contents of the enable file. You can see that it's currently disabled. Let's see what duty cycle is set as. It's set as 0, and period, it's set as 0 as well. So what I'm gonna go ahead and do is enable the pin, set the period to 100 milliseconds like we did in the previous example, and set the duty cycle to 50%. Hit enter, and now you should be able to hear the buzzard. Now if you had other stuff connected to any one of these other pins, 21, 22, 14, 16, 13, or 19, now with this second method you should be able to cd into one of these other folders, and you should be able to control them, whereas using the first method you weren't able to do so. Now in my next video I will show you how to configure the pins on your BeagleBone Black Debian 8.6 as PWM pins but using C++. That's it for this video. Thank you for watching.